Hey data lovers, welcome. I'm Nick. This is the first in a new series of events, short events, in which we do data science open source code alongs. That is to say, I'm going to be showing you an open source library, usually a Python library, or an open source data science tool, which I really like, which is useful to me, and I'll walk you through a quick demo to show you some of its functionality, the way it might be able to add value to your pipeline, and that way you don't have to work your way through the tutorial yourself. Just watching this short 15-20 minute video will help you make up your mind on whether or not this tool is useful to you. Now, I'm running these events out of the Data Science and AI group of French Tech Singapore. If you look on the screen there below me, you see a QR code. If you scan that QR code, you'll get a link to join our WhatsApp group. Right now, there's about 200 members in the WhatsApp group, varying from data scientists to engineers to CDOs at very big international companies to data enthusiasts and people who are just learning about data science. A very nice mix of individuals who all share one common characteristic, is that they really care about data. So scan the link below and join us in the WhatsApp group. Hope to see you there. Today we'll be looking at a Python library called Lux, which is designed to help you speed up your exploratory data analysis. And it does so in a very neat way. Lux is designed to integrate very tightly into your data frame object, which I'm sure you know quite well and which you spend quite a lot of time in. And it allows you, through the addition of a couple of widgets, to very quickly explore relationships within the data that you're working on. So let me just show you. I'm going to take a quick walk with you through a demonstration Jupyter notebook that was made available by the Lux team. At the end of this video, I will also share a link to the GitHub repo and to this notebook so you can check it out yourself. Once you've got Lux installed, it's really very easy to start using it. As easy as typing import Lux. So here I'm just going to import it along with pandas. And I am going to just pluck the demonstration CSV file from the internet. Now, what's great about Lux is that it really preserves the pandas data frame semantics. So it means that you can just apply use the same commands that you're used to, and nothing really changes. Here, I'll show you. If you have a look at the data frame, I'll just rerun it to make sure that it's up to date. This is what it looks like, right? This is the kind of old-fashioned data frame that I'm sure you're used to. So this particular data set is all about countries. Let's have a look what's in there. Country, subregion, life expectancy, well-being, number of happy life years, inequality measures. Then there is some stuff about GDP per capita, population size. All right, so these are statistics on different countries. Now, what's great with Lux is if you run your data frame, you will see this little button in the top left, which says toggle pandas/Lux. If you click on it, you launch the Lux widget, which shows you directly in the data frame a bunch of different analyses. So here, for example, you have a couple of different tabs: correlation, distribution, occurrence, and geographical. This is all extracted completely automatically out of your data frame. Under correlation, you see the correlations between different variables in the data set. And that's very typically something you start out with, right? You start out looking at which variables are related to one another and which are correlated. So here, for example, we have average well-being and inequality adjusted for well-being. Not exactly sure what that is. And there's apparently 12 more charts. Let's have a quick look. Right, life expectancy, inequality adjusted life expectancy. There's a lot of variables that have been adjusted for inequality, and we'll remove those later just to get a better look of what's going on in the data. But as you can see, it's very easy to get these plots. You just show your data frame, you click on a button, and you already have the correlation plots directly available to you. The distribution is also very useful. So here we have the univariate histograms for the quantitative attributes, number of records, population, GDP per capita, etc. Again, there's a bunch of different charts here, depending on how many variables you have. And what I find very neat, so this clearly is geographical data. Lux recognizes that and automatically adds world maps, which I think is just super neat. So here you have the number of happy life years, and you can just, in a single glance, see that people in the West, well, in the civilized countries, I should say, the well-developed countries, have a higher number of happy life years. And again, this is without doing any work, just importing Lux, importing the CSV into your data frame, and off you go. Now, what I like a lot about Lux is that you can keep doing this. So as you modify your data frame, as you add variables, as you consolidate variables, as you merge them, as you delete some, you can keep visualizing the data very easily, and it can really help you to drive down in your EDA. So for example, if we make just a couple of small modifications, so for example, we add an additional feature column describing whether or not the country is part of the G10 list of countries. We drop all of these measures that I was talking about before, these inequality adjusted measures, because they're very strongly correlated anyway, so they're not super interesting. And we recode the countries a little bit, just to make them a little bit cleaner. So what I mean with that is that, you know, there's, depending on the name, there are official country codes, and you should probably use those. That makes it easier to analyze things. And we can take some of the data to add some information on the number of bordering countries, which might also be interesting. Just do a little bit of data processing. It really doesn't matter too much what's going on here. What matters is the end result in the data frame. Okay, so now that we've cleaned our data a little bit, let's have a look at the data frame again. Looks pretty much the same, right? There's here are our new variables, so the number of official languages spoken, the number of bordering countries, etc., etc. Let's launch Lux. See what's going on there. All right, so again, I have my correlations. I have inequality. Oh, let me just scroll down here. Inequality, life expectancy, number of happy life years, average well-being. So this is pretty, self-evident information, right? So if there is less inequality, you probably live longer and you're probably happier. I mean, it just makes a lot of intuitive sense, I guess. Geographically, you can also just very quickly have a look at the same data here. I have a little bit of trouble scrolling to get it in the screen. So happy life years distribution around the world. Again, well-developed countries. You live longer, you live happier. Oh, there's a mean of population across the world, right? So China sticks right out. Again, average well-being, GDP per capita across the world. Get nice geographical maps for that. Inequality across the world. So all very, very interesting. Now, this is very interesting if you don't know what you're looking at, right? And this is a good place to start. But what if you do know what you want to look at? So, for example, what if what we're interested in really from the start is inequality and life expectancy? Well, Lux has this super interesting feature where you can steer the analysis with your intent. So let's say that you want to investigate whether any country level characteristics can explain the negative correlation between inequality and life expectancy. And we can start out by doing that by saying to the data frame that our intent is to look at inequality and average life expectancy. Super easy syntax, right? Just df.intent, data frame intent. You list your intent variables, and it automatically steers the analysis in the right direction. Again, I launch the Lux widget. And here you go. Oh, this is the one. I didn't have the right image there. So here in the current visualization, we see the analysis that is based on our specified intent. Average life expectancy versus inequality. And then what Lux does is it proposes a further breakdown. And this is where it gets really interesting. Let me see how I can get this in the screen for you guys. This is a bit of a hassle here. Okay, let's see if I can. Okay, I'm gonna have to zoom out on my screen. The code might become unreadable, but then at least you will be able to see the plot. Hold on. All right, this is better. So here we're breaking down the current visualization based on intent that we have here a little bit further. So this is average life expectancy inequality with annotations for whether or not countries are part of the G10. And Lux proposes a whole bunch of different enhancements like this of the initial visualization. So here, for example, we see the same relationship, but with the different regions of the world, which is just outside the streaming window. But you have the Americas, Asia Pacific, Europe, and you can sort of see where in the world there is less inequality and there is a higher average life expectancy. Then if you click on filter, you get the result of Lux applying different filters to this relationship. So here you see the relationships for all the countries where the number of official languages spoken is free. That's not very interesting, I guess, as a filter, but you know, it filters for all of the other variables that are available within your data frame. Here, for example, you have only the Middle East, or countries with free bordering countries, or countries with 6 bordering countries next to it. So as you can see, once you know what you want to look at and you specify the intent of your analysis, then Lux automatically applies a bunch of filters and enhancements that really help you understand what's going on in the data set very, very, very quickly. Now, before wrapping up, I want to have a look at what happens if we expand the data with some additional 1D data on, in this case, COVID response. So there is this COVID stringency dataset, which is basically a measure of how strong the COVID response of different countries was. I think it's a measure between 0 and 100, where 0 is no action at all, and 100 is full-out panic mode, with borders being closed and everything. And we're going to have a look at that to see if that's correct. Now, if you want to do some quick and dirty experiments with visualization in Lux, you can. There is a visualization sublibrary, and you can just sort of quickly visualize, really with a one-liner, super easily get, you know, here in this case, just some quick distribution information. And then this is the same distribution information, but for, let me zoom back in here because I changed the, this is the same visualization information of the stringency measure, so the strongness of the anti-COVID response between 0 and 100 in the very early days of the pandemic. So there is apparently a whole bunch of countries which did not so much, almost nothing, I guess, and only very few countries which reacted very strongly very early on in the pandemic. Okay, now let's merge this data set with the country data that we already have. And let's tell Lux that what we're interested in is really the stringency data. So we're interested in further understanding the strength of the initial COVID response. Again, I have the same data frame, but now I have this stringency column, which is right here, which represents the initial COVID response. We see, for example, here that Yemen apparently did almost nothing. And that Vietnam apparently had a pretty strong initial anti-COVID response. We have a look in the Lux widget. So here we see the current visualization based on our intent, which was the stringency. So here we just get the histograms here, the bint histogram with the number of records. But let's see what happens when Lux enhances that analysis. I have to zoom out again just a little bit to get the graphs on the screen. So now it becomes interesting, right? We can now immediately see that apparently on the geographical map, apparently only this country, guess which one it is, had a very strong COVID response in the very early days, and apparently also something in the Middle East and what looks like Italy. So this is early on in the pandemic when I would guess, I didn't check the date, I should probably check that to be sure, but I think when COVID already went from China to Italy, right? And so we can see that even at that moment, Europe and the US were doing nothing. Such a regrettable decision, retrospectively. Okay, so let's have a quick look at the other charts that Lux provides. Average life expectancy versus stringency. Oh, that's interesting, right? So the higher, so this is, yeah, it's not a very strong, not much going on there, but it's interesting to look at that plot, right? Inequality and stringency. Also interesting, population and stringency. So let's see, so yeah, so okay. This is interesting, right? Because we have two outliers here in terms of stringency. And this is, in terms of population. And this one has a somewhat low and this one has a very high stringency. But we see that it's not dependent on population size, right? So you can have a low population size and respond very stringently, but it's also possible, apparently, people to have a very large population and still respond very adequately very early on in the response, in the pandemic. Of course, we know which country that was, right? That was most likely China. Oh, oops, shouldn't have clicked on this. Okay, so we get a bunch of interesting graphs here, right? Again, the filter is might also be interesting to look at. Though I don't expect there to be a relationship between, for example, the number of languages spoken and stringency. Right, so GT equals false, so those are the countries that are not in the G10. So you can just have sort of an exploratory look here. Now let's drill a little bit further down and make it a little bit easier to understand stringency by binning it. So instead of saying, okay, we have this score between 0 and 100, let's just bin it into two categories of high and low. And let's go back to our initial intent, which was to look at inequality and average life expectancy. So I communicate that intent to Lux, again, by saying df, which is now called result here in my code, df.intent, and then I specify the list, inequality, and average life expectancy. If I go back to Lux, I get my current visualization here, and now we're back to on the y-axis average life expectancy, on the x-axis inequality, and now it becomes super interesting. So now if we have a look at the enhanced visualizations, we immediately see something interesting going on here. So this is average life expectancy and inequality, and Lux plots, so color codes, high and low levels of COVID response early on in the pandemic. And so we can immediately see that countries here with very high average life expectancy show a much stronger initial COVID response than one with a very low level of average life expectancy. And again, we saw earlier that that was related to having a higher GDP, having lower levels of inequality. So these are the developed nations, right? At least we would be forgiven for thinking that, because we can see that there's a few exceptions. It's hard for me to zoom in here, but I'll hover over them. Here there's at least 3 blue dots, which are sort of exceptions to this observation. So here we have one blue dot, which is a very high COVID response, but a 0.4 inequality, not very high average life expectancy. And there's 2 other ones. There's even one which has an average life expectancy of only 60. So that's super low. Probably not a very well-developed nation. Here's 63. So those are probably very interesting data points to look at, right? Let me just, for good measure, have a quick look at some of these other visualizations that are provided. This is life expectancy inequality versus G10. That's all of the stuff that we saw before, right? Okay, so that's nothing we're really interested in for now. Let's have a look at the countries that are exceptions, apparently, to this rule. See if I can zoom out a little bit. All right, so that's good enough. Okay, so these are the 3 blue dots that we saw on the graph. Afghanistan, Pakistan, and Rwanda. Wow, where apparently there was a very high, stringent, very strict initial COVID response. I did not know that, especially for Rwanda. I had no idea. Afghanistan, I wonder if that's related somehow to the war and the invasion going on. The military presence, the very strong military presence that was going on there at the time. I'm not quite sure what to make of this, but this is definitely interesting data, right? Based on this, you would sort of want to look into this further. And this would be an interesting insight to share with your team or with the people working with you. Now, the interesting thing about this is if we're interested in this, right? If we say, okay, this is an insight that I want to share, we can just click on the graph that Lux generated, and we can click on this little export button in the top right, and that will export it into the exported property of the data frame. It goes directly into the data frame. So if I look at dataframe.x, let me get it in screen. Let me zoom out a little bit. Zoom in a little bit. All right, here we are. If we look at results, which is my data frame, .exported, we see that the image that we selected was there, right? So at this point, I can just screen grab it if I want to share it with someone. Or what I can do, which is a super neat feature of Lux, I can generate the code I need to get a nice Alt-R cell, for example. So here I can, instead of writing that code myself or reusing code that I previously wrote, I can just say, okay, print results.exported. This is an array, so there can be several figures. This case, there's only one. We're going to grab it and we're going to say to code, which generates the code formatted in this way. You can have a look at the API if you want to read about the different options here. When I run this cell, it just generates code for me. So it says import alt-R as alt, define a chart, encode it this way with this kind of data, create a chart, yada, yada, yada. So if I copy paste this and I run it, then it automatically generates a nice image for me that I can easily share, with my team, or that I can easily integrate into a presentation or an HTML document. So all of this visualization, all of this data exploration was done completely out of the box with Lux and within the context of the data frame. So what I really like about that is once you start playing around with your data, enhancing your data, cleaning it, then it's just really useful to be able to take a deep dive into what's going on in your data directly in the data frame without having to do anything else. And it just really helps steer and facilitate the whole data exploration process. I hope that was useful to this. I hope this was useful to you. Next time I'll try to share the live event rather than a separate recording. That's what I was supposed to do today, but I forgot to click on the record button, so my bad. In the meanwhile, if you want to join us, again, there's a QR code below me. Join us in a WhatsApp group. Hope to see you there, and stay tuned for the next event. See you.